So, good morning, everyone. I welcome you to our course on collective dynamics of firms. My name is Frank Schweitzer. I'm a professor of systems design at ETH Zürich, and I will teach this course myself. I hope that a few more of those students who have subscribed will appear here. So there are actually, I think, 26 or so that have subscribed to the course. If you happen to know why some people are no longer interested or drop out from the course, so we would be really interested to know this. Some of you may have realized that I teach 2 courses during this semester. The other course is on economic networks. Is there someone participating in both courses? You, right? So for all the others, there is some overlap, of course, in subscribing to these courses. Economic dynamics, I would say, is the most advanced course we teach. At the same time, it's also discussing formal concepts a lot. This course is not as ambitious as economic dynamics. It's more hands-on. You do something, you do a bit of math, something you know. You deal with equations, you deal with data. It gives you a more comprehensive view of a real dynamics. And what I like about this course is that the things you learn here in terms of how to treat data, how to build models, that's something you can use in many other areas of scientific disciplines. So this is not very specific on companies. So if you ask me which of the courses I like most, then I can say this one, so, okay, of my courses. I also teach another one in the fall. It's called Systems Dynamics and Complexity. This is a very basic course. It basically covers dynamics from a systems dynamics point of view. So that means we deal with nonlinear equations, and then we look into control parameters that allow us to reach different scenarios and so on. But we never explain how we get the systems dynamics, right? If you think of whole issue from a conceptual point of view, then there must be some entities, economic actors, that interact and generate the systems dynamics. It's nice that we can afterwards describe systems dynamics by a set of nonlinear equations, but how do we get that? So that's a challenging question, and this question is answered in this course. And to some extent also answered in the economic network course. So let me start with a few formalities here. Let me move this. The course is an elective course in the MTech master program. It's also listed in other programs like elective course for physicists. Is there any physicists here? The 2 of you, good. So you will probably recognize that what we are doing is very much inspired by statistical physics here. That's on purpose, yeah? So, okay. It's also listed in mathematics, no one, and agriculture, I think. Yeah. We have provided you with a website in Moodle where you find all the material. What do we mean by all the material? We mean these handouts, and I managed to inform you in due time that you should hopefully download this. The handouts contain all the slides that I show in the lecture and a note field. Sometimes I write the references to literature that we have used in order to create the slide. Sometimes I give general comments on how to understand the slides or things like this. But the notes part is basically for you to take notes. It means I expect that you have a few important notes to make during the lecture here. That's the idea. So therefore, some of these fields are empty, so you can fill them up. The second important material you find there are the self-study tasks. I will comment on this a bit later in detail. Each of the courses we teach has a theoretical upfront teaching part and a self-study part. We want you to learn something. We want you to do something yourself. And in our particular case, the self-study task is about dealing with data, learning how to get certain features that we describe theoretically in this course, how to get this yourself, and to compare the figures that I show here with the figures you produce yourself. So no matter whether you care about firm dynamics after this course or not, this is some skill that you can use in most other fields. Let me remind you on this. Then we also put literature in the Moodle platform. This is meant as an additional information to you. Sometimes you would like to look into the original paper. What did the author say about these figures in comparison to what I said about it? Then this is available to you. We encourage you to look into these things. Sometimes also interesting for historical perspectives. And you see how Herbert Simon has argued about these things like 50 years ago. That's also interesting. But it is not part of any further check or control. Then we also give you parts of code that you can use, in particular code for the statistical software R, that you can use in order to run your own programs and to educate yourself. And last but not least, the Moodle platform is also for communication among you. There is a forum where you can discuss about the self-study task, but there is also a forum where we communicate to you. So who is we? The professor, of course, but also the assistant of this course, that's Pavlin Mavroviev. I'm not sure if some of you have met him before in the lecture Systems Dynamics and Complexity. Who attended this? Okay, so then you know Pavlin already. Pavlin has developed most of the self-studies for this course, so he is really the skilled person to discuss why certain things may not have worked out for you and so on. There is also a student assistant working for this course, Natalia Frey. She is responsible, for example, fixing the errors that we detect every year. So we also redo the slides every year. That means we produce new errors, and if you see one, then please point us to this. Oh, what did I do? I pressed something, right? The S was not intended. All right. So I have to be careful here. Okay. So the exercises are mandatory in the sense that you first have to submit something to Pavlin. That is why we use the email address that is on front of the handout. So that's an email address you should write to regarding everything about the course. You can also write me personally, so then it's read by my office administrator. If you want to write about the course, and you write on this address, and then we look into this. Okay. So the groups, you should form groups in order to solve these exercises, to discuss certain things as well. And these groups will be randomly assigned. Pavlin will usually do this. He will also take care if some new people enter the course or some people drop out, and to rearrange these groups. It eases the effort of doing the exercise and presenting something here. Okay, you can read this in detail. Then we have a test start every month. That is an online test start, which you do at home. Basically an open book test, if you like, where we just control whether you were able to follow this course. You have hours enough to do this test. You can use all your material in order to answer these questions. This will be multiple choice questions. It is simply to give you an additional feedback about what you understood from the course and what not. And for us, it's a good control to see the same. You have to pass 2 of these test starts in order to be eligible to take the exam at the very end. So, if you do not participate in the exercises, that's the other condition, and if you do not use the test start, we are pretty sure that you are not able to pass the exam. So, these are mandatory conditions for good purpose. And then we have a Sessionsprüfung, an exam during the summer break, which is arranged by the rectorate. It's a written exam, closed book, no additional help material, but it covers not only the lectures, it also covers the self-study tasks. That's very important to understand. Are there any questions from your side regarding these formal things? If not, then we just continue with the further description. If there are questions, you can either ask them right away, or you contact me during the break, or before or after the lecture, or you write to this email address we have given to you. Yeah, this one here. All right. So, why do we give so much importance to the self-study tasks? I already explained this on Tuesday. So the Bologna process requires that 30% of your time is devoted to self-study tasks. It's not the professor who teaches you all the things and you just listen and sleep or whatever you want, yeah? Read your emails or so. You have to do something yourself. And therefore, we have created the self-study tasks. But in addition to the self-study tasks, there are other elements of self-study. One element are the questions that are listed at the very end of each lecture. These questions are not the examen questions. The examen questions, let me repeat it again, are much more tougher than the questions at the end of each lecture. The questions at the end are meant to help you to repeat the material that I have just presented. Yeah? There is not a one-to-one match between these questions and the exam. In the exam, you really have to do a bit more. So then, as I said, you have the self-study tasks where you form small groups and interact. And then you go to the exercises and discuss with your fellow colleagues. We understand that there are mistakes, for example, in the exercises, but in the self-studies that you deliver, but the exercises are for finding out what went wrong, right? So this is nothing where we assign grades or something. It is a platform to discuss issues that came up when you tried to solve this. At the end, you will have a considerable skill in handling data, for example. So, okay, I don't read this for you. The first thing is, of course, that you form these self-study groups in order to be able to start with the self-study tasks. I will explain the first self-study tasks later in the lecture. It's a very easy task. You could probably do it yourself, but we want you to interact a bit with other people. You know? So, and then if you have questions, you can use the Moodle forum, or if you have specific questions and have to send in your solutions from the self-study tasks, you always use this address. Right? So, okay, with this, I come to the content of the course. The first thing I should explain is what this course is not about. Collective dynamics of firms sounds a bit like, yeah, dynamics of firms. So most people drop the issue collective because they don't know what this means. So let me start by explaining what the course is not about. It is not about individual firms. If you participate in the MTech Master Program, then you know that there are ample of courses that are just devoted to individual firms, to strategic issues of firm development, to management issues, to economic issues, and so on. We are not talking about this in this course. This course is very different from those other courses. It's not our interest to talk about a particular firm, ABB, and what ABB should do in the next 5 years in order to improve its standing in the market or to get a growth rate that's expected by the shareholders or something like that. Not our topic at all. We also do not predict the future of a given company X. You learn in other courses how difficult it is. We will predict the future, but not with respect to a particular company. So then, what do we mean by collective dynamics of firms? We look into what happens if we think about not just one firm, but thousands or millions of firms. How many firms do we have on Earth? Can you give a rough number? I mean, firms we know about. There are many firms we don't know about, firms who don't pay taxes to the government or file any sort of reports, right? Or there are maybe governments who do not collect all the data from the firms and we cannot know about it. But what's a rough estimate of the number of firms we know about? Just the order of magnitude, what do you think? $1,000? Million, yes, okay. How many million? 9 million. Anything else? No clue. We know about 50 million firms. So, that is the number of firms where we know the name, we know the location, we know probably the tax they pay to the government. We have a track history. We know who's the CEO or the head of this company, and so on. So I'll come to this in a moment. And now let's assume that all these firms have some business with each other. These are not isolated firms in the market, right? So they compete for selling their products to the same market, for example, but they also collaborate in order to develop new products and have a comparative advantage against other competitors and so on. And it's difficult to observe the strategy of a single firm, right, and how they position themselves on the market. Let's think about UBS or something like this. You cannot really know about the strategic decisions of that kind of bank, right? Because that's part of their business model and they will not print it in the newspaper. But what we see is if all of these firms interact, we can see the collective dynamics, the dynamics on the systemic level that emerges. And we would like to first explore this collective dynamics. What do we see? And then we want to go one step further and want to ask, okay, if we know now how the dynamics of all these firms look like, are we able to make assumptions about the dynamics of an individual firm? That's a challenge point here. And we cannot, as I said, specifically deduce this dynamics of an individual firm or the growth strategy, but what we can do is we can provide reasonable assumptions that are compatible with the macroscopic dynamics that we observe. And this gives us enough reason to hint on regulatory issues, policies that should be set up in order to encourage firms to grow or to be established and so on. So the result of our investigations are, as I said, not specific strategies. The results are statistical laws of firm growth. I come to this in a moment. I'll give you an example. These slides, as I recognized yesterday again, very much rely on text, right? So I try to give a live and lively performance here in order to give some illustration to these plain facts here. Public thought it's fine to have just this text because it's introductory. We will have more pictures. Okay. So what we would like to find here are statistical laws. I come to examples later. Yeah? So we have divided the material of this course in 3 parts. The first part is about modeling. Modeling is not the first part in the course. That's the first part on the slide. The first part in the course is data analysis. Maybe we start with number 2 here, because this goes along. We assume that we have data about these firms. And for our exercise, if we use about 10,000 firms, and we learn how to analyze this data statistically. For this, we would like to find out about the distribution. For example, if I give you the size of the firm in 2008 and the size of the firm in 2009, then you can first plot the distribution of the sizes in 2008. You make a histogram, you bin the data, right? And then you plot the distribution of the sizes. What do you get by this? Let me use this blackboard as an exception. So let's assume that's the firm size, and then P of X is the empirical distribution, actually the histogram that you get from this data. So you bin this here, and then you get a curve like this. So what is the underlying message if you see a distribution like this? Let's assume it's a normal distribution or something, please. Yeah, let's assume it's a Gaussian distribution, right? But this is a mu, and that's a sigma here. Yeah, okay. What would be the message if we were able to find a distribution like this? Yes. Right. So if we find a distribution like this, and we say, well, interesting. The firms seem to have a typical size, namely around the mean value here, right? And then the economists say, well, if we think of an evolutionary process that establishes, there must be some kind of optimality behind this. What's the optimal size of a firm, right? So that means then we start discussing what internal processes or external processes in terms of firm-firm interaction or whatever tax to be paid to the government result in this optimal size. But what I can frankly tell you is we don't find this, right? Because there is no optimal size for a firm. You already know some of the successful firms are very large, and there are some successful firms that are extremely small, right? So. Okay, we find something like this. Okay, that's what we find. What's the interpretation of that? Right? Okay, let me stop here at this point because we discuss this next week, right? But your first exercise after this would be getting these distributions and then start thinking of what's the meaning of this. If I find a distribution like this, can I say anything about this? Is there any regularity behind this? If yes, what kind of regularity is it? So, for example, can I scale the function against the size and then get some universal distribution, as we know from other theories, for example, in statistical physics? Okay, that's the first part. And then we have all these distributions, not just about the size. There are other distributions as well. For example, if you have the snapshots of 2 consecutive years, what can you then also calculate? Obviously, of 2 consecutive years, the change or the growth of the firm, the annual growth rate of a firm, right? I mean, for this particular firm, it may be a bad year, right? But if I talk about 10 million firms, so then the statistic is probably rather good, right? So that means we do not get just this distribution about the size, we also get some about the growth rates. And then we look into the distribution. What do you guess? It's a symmetric or is it an asymmetric distribution? Any hint? Just speculate. If it is an asymmetric distribution, what would be the economic consequence of this? We're talking about growth rates of firms here. Any guess? It would mean that the growth is more likely than the shrinkage, right? If it is has a bias towards positive growth rate, right? That would please the economist, right? Because the economist is obsessed with growth, right? Economic growth. That's what we want to have. So, okay. Let's check whether this is true on the level of the firms, right? That's something we can find out. And if the bias is on the other side, the negative side, what's the message then, right? Do we have a shrinking economy? Do we have a collapse of the whole economic system? What are the consequences of this? And what are the consequences if the distribution is symmetric? We will discuss this next week, but these are the ideas that are related to this. So then, after a few lectures, we stop and then we see we have a number of what we call stylized facts. These are all the statistical laws where we find some regularities. You do not expect this regularity if you think on a particular firm, but if you think of millions of firms, then you see this regularity. So that's what I sell starting next week. And then we have to ask ourselves, okay, but these distributions are made up by individual firms who grow or shrink each year. What is the dynamic on the individual level of the firm that is compatible with this kind of distributions that we see? Right? That's our question. And once we have identified this dynamics, then we can ask about the economic meaning of this dynamics. We go basically from the top to the bottom. And then we end up with stochastic growth models of firms. Do you know what a stochastic model is? Have you got any experience with this in other courses? Yes, yeah, of course. Yeah, okay, it is a probabilistic model where random forces play a considerable role. I give you a very simple idea of a stochastic model. So, x of t plus 1, that's the time, is x of t plus some random shock that is added to this actual value, right? So this can be also negative. Then we talk about a shrinkage of the firm. It can be positive than the firm growth, right? So that's a stochastic model because this is a random shock. This most simple thing we can think about. The physicists know that this relates to Brownian motion or to random walkers and so on. So is this a good proxy for economic growth? Right? So that's something we will discuss. We will find out that not a good proxy, as you can guess. But surprisingly, we find that this is a good proxy. T plus 1. So we have a multiplicative process. So multiplicative means there is a growth rate here that's multiplied with the actual size. And this is a stochastic force. Wow. You can describe the growth of an economic entity like a firm by using an assumption that heavily depends on random forces, right? That's a bit of a surprise because you think of firm growth in a more deterministic way. So what's the difference between this model and your initial assumption that there is a bit more than just random forces behind it? You are right, of course. But this points back to the issue that I addressed before. We are not interested in talking about a specific firm here. For a specific firm, we would probably have better assumptions here. But if I talk about 10 million firms, then this is a good proxy for the individual growth of a firm, because when I aggregate all of these processes, then I get exactly the distribution I have seen empirically. You understand? I cannot make a prediction about a single firm, but I can give you a probability that the firm of that size had a growth rate like that, for example. The same as with buying a lotto ticket, right? So you do not know exactly what's the number that they draw next Sunday, yeah, but you know the probability distribution that this number will be drawn. Right? Okay. You understand this idea? So then we talk a lot about these kind of equations and how they are linked to economic growth, in particular to growth of firms. So, but we also talk about formal concepts here. And I start with this today. Why are we interested in this? What are the kind of conclusions in an economic sense that we can use from this? What are the conditions to boost or to enhance economic growth that is based on the growth of companies? Okay. So this slide says more or less the same as I said before. It shows you the structure of the course. So the first five lectures are dealing with this data analysis and the empirical facts. So at the end, we know what we call stylized facts here. What's a stylized fact? It's a statistical regularity. You would not call this a law. Yeah? You would call it maybe a statistical law, or the economist says a stylized fact. So that is what we find about the firm size distribution, about the firm growth distribution, about the relation to age. If you are a very old firm, how is the age of the firm affecting the growth rate, for example? That's a very interesting question. So these are things we find there empirically. Then we go and model these processes. By means of these stochastic equations I have described, we go through this step by step. You should not fear that you get lost because of you have never dealt with this kind of dynamics. I mean, the course is essentially to teach you about it. And then gradually we add more economic assumptions to this picture of interacting firms. First, we look into what do we get if firms are kind of independent. And then we look into what is the effect if the firms start cooperating or if the firms start competing. What is the outcome on the dynamic? So that means what we do is different projections of the whole picture if we have further assumptions closer to economy. Okay. This is the last overview slide, I think. So I have divided it into how and why. Okay. So the how relates to the skills that you obtain during the course. So first of all, you learn to use this state-of-the-art statistical software. I'll come to this in a moment. You also learn how to build up multi-agent models of interacting entities. In our case, these are firms, but if you are from biology, then you immediately realize that you can use the same assumptions and the same techniques also in other fields, namely in biology, for example. And you learn how to squeeze out from these data and these models some regularities. Because remember, these are phenomena that rely on lots of fluctuations. How do you squeeze out the regularity behind this? That's what we learn here. But then it's not only a technical course here, it's also a course that tries to explain why we see this kind of dynamics. The first and most interesting question is, why do we see a kind of universality here? Because intuitively we are all convinced that each firm has a different CEO or managing board, and these do their very best to make the strategy of the firm unique, different from the competitor, right? But still, on the aggregated level, we see a kind of regularity. So how does the two things match? On one end, the struggle to be different from other firms, and on the other end, the more or less universality of the dynamics that we observe. That's a surprise, right? And we will argue why this is. And on the other hand, I mean, if we see this kind of universality, then we clearly understand that this allows us to have some prediction also about the future. Not on the level of an individual firm, as I said, but on the level of the economy, for example. So, we also discuss the issue how firms choose different interactions like cooperation and competition. Initially, you would assume it's good to win against a competitor, right? So you are the Apple CEO and you got the iPhone on the market, and because of this you do not like another company called Samsung who comes with another phone, and then HTC which comes with another phone, and they all look quite similar and have the same functionality, right? Your idea is to kill all your competitors. What do you gain by this? You can think a moment, right? Then you rule the market, of course, yeah? Everyone has an iPhone. But you also wiped out all these companies that are sources of innovations, right? So that's an important thing. Your competitor is not just a competitor, it's also a source of innovation. This drives the growth of your own company. This is something that you observe, that some competitors keep other competitors alive, right? So we will talk about this example of Gillette versus Wilkinson. So that's a shaving company, right? So Gillette has about 3/4 of the market, and Wilkinson and all the other companies have 1/4. There were several possibilities in the past to just take over Wilkinson and then to rule the market. They didn't do it, right? They kept their competitor alive because they learned that from this competition, the market grows. But if there is only one company that rules everything, the market will not grow. So that's an intuitive understanding of how firms interact. But how do we put this into the model? And how can we see that firms do better by keeping their competitor alive? That's something we will answer here, right? So, and then we also look into how the market is driven by innovation and how innovation succeeds in a probabilistic model and so on. So, okay. There any question about the outline of the course? No? If not, then we start by talking a bit about the motivation behind it. So, if you want to place this course in somewhere on the map of economic theories, then we belong to industrial dynamics or industrial organizations. So that's the topic of the course. Sorry, I have to be a bit careful here. So what is industrial dynamics? This is a part of economic theory, economic thinking, where we look into the conditions and the dynamic processes that govern the birth, the growth, and the death of firms and industries. It sounds a bit like biology, right? Birth, death, and growth. And in fact, as you will see, the lifetime pattern of a company is not very different from the lifetime pattern of a human, right? There is birth and death. There is growth. There is saturation or maturity. You will always see this in the dynamics of these firms as well. And what we are interested in to find out how can we describe the conditions under which firms are born. Because if we consult for the government, so then we would like to give hints under what conditions more firms are born, right? For this, we have to understand empirically and also theoretically what's the impact of lowering taxes on the birth rate of firms, and what's the impact of rising taxes on the death rate of firms. And it's not as simple as you may think about it. So these are things we discuss in industrial dynamics. So in particular, we look into these stylized facts about the firms. How can we describe this? There are other issues like productivity and so on. And our aim is here to get an insight into these regularities. If we have this insight, when we can make predictions about the future, but we can also control the dynamics to a certain point, right? We know what to do if we see a steep decline in firm number, which we call death here, right? So then we know what to do from these models and from the data. So what are our control parameters to keep this within limits, for example? Okay. This is the next two slides give us some examples here. So the first example why we should know this is related to market power. You can assume if we know about the firm sizes, then that's a good proxy about the market power of a firm. You can use other proxies as well, sales rates, for example. No? If you think of these browsers here, you can think in terms of download numbers, of course. That's another proxy for market power. But it's very clear if you compare different firms and you do not have a clear whatever relation to the market power, you use the size of the firm revenue as a proxy of its market power. So if firms have a large control over the market, this is not always for the best of the customer, right? Because then they can also control the price, they can drive the direction of the technological development into a direction that they prefer. Take the example of Google or Facebook, right? So that means we should understand how market power is related to the welfare of the consumers. And for this, we should know how to proxy market power. So here there is this example of the different browsers that we competed a couple of years ago. So most of them you will not remember anymore. So. But if we know why some of these companies have gained in size and in market power and others not, then we can, for example, tell the government what to do in terms of antitrust policies. Is it really necessary to keep this company alive? Is this the best way of preventing other companies from ruling the market, or are there other ways of preventing that a single company dominates the market? You see, first we need to understand the empirics behind it. So this is the second example, and with this I stop because I assume that the bell is ringing in a moment. The impact on employment policy. So firm size is a very abstract notion, right? How do we proxy firm size? We proxy it by number of employees, right? So we measure it by a number of employees because that's a number that we know quite well. It's also reported. So, and if we talk about birth and death, and we talk about the creation or the destruction of jobs. And what we find that there is a large probability for a large firm to collapse or to die, right? Then, of course, this has impact on the job market. It leads to recession, to all sorts of things. So that means we should understand what are the determinants of size in order to give hints, for example, to employment policies. We can prevent, for example, unemployment either by keeping large firms alive, influencing their probability to die, or the other way around, by increasing the probabilities that new firms enter the market, right? That's another way. And of course, a big guy dies, but thousands of new firms enter the market that are interested to hire experienced employees, right? So that means that these people who are laid off by the big company then find immediately a job in a smaller company that is happy to build on their previous experience, right? And we have to understand all these things. We have to understand what is the influence on birth rate, on death rate, what's the influence on size in order to make this kind of policy advice. With this, I stop here. When the bell rings the next time, we continue. So I suggest that we just continue. I'm a bit confused to not hear the bell, but this happened on Tuesday as well. So, as far as I understand it, the correct way is that we have a 10 minutes break from 11 to 11:10, and then we have another 45 minutes to 5 to 12. So that is my understanding of the ETH rule. So, and maybe from next time, with or without the bell, we make sure that this works. Okay, so let me come to the methodology that we are going to use here. This methodology is in line with other quantitative sciences like physics or chemistry and so on. That means we have an empirical part there where we identify what we call the stylized facts, namely the robust statistical patterns in the data. And this is similar to what Kepler did with the astronomic data, right? So he looked into the astronomic data and was able to deduce this to a quite simple law, which is called Kepler's first, second, and third law. But he could not give an explanation why it was in the data. Nevertheless, he developed a very interesting theory of what he thought is the origin of the empirical laws he has discovered. Right? It's very much related to theology. So I recommend you to read it. He was able to find the 5 Platonic bodies in these ellipses and so on. It's a very nice work, right? So, but this was his explanation. In fact, what he discovered and what still remains is the empirical law. And then a person like Newton was able to derive hypotheses on how mass bodies should behave. And this was the underlying principle, the law of gravitation, which then led to an explanation of what was seen empirically. So, and in a similar way, we do the same. We identify first the stylized facts, and then we make hypotheses, of course, in this time about the economic behavior, and try to reproduce what we observe in terms of a collective dynamics. That's the idea. So with this, I come to our empirical source. We already estimated the number of firms to 50 million. That's the firms we know about, I said. So how do we know about this? Usually from databases. There is one database that we also use for the course here. It's called the Amadeus database. It contains of about 9 million firms from 38 EU countries. And you see each of these firms have a specific profile there, which tells us about the shareholders, the managers, the firms that are owned buy this particular firms and so on. And then there are also relationships between firms and shareholders and so on. We have developed a nice data browser, which I just run here, that shows you what happens if you browse a database, right? So we started from a company. Here you see all the data that is stored in this database on this side. And we started from a company that you probably know, Co-op, and then we looked into how is Co-op related to other companies, right? So, and then you see the subsidiaries of Co-op listed here in the neighborhood. Yeah? So all these companies you probably never realize as a subsidiary or daughter of Co-op, but there are some that you already recognize. So these are the first order neighbors. Yeah? There's a direct link from Co-op, and in most cases there are 100% of ownership here, right? So now we can increase the resolution, decrease the resolution a bit by going to the second next neighbors, right? And you see other companies appearing here, yeah, in the immediate neighborhood of Co-op. So we can also zoom out a bit in order to make room for the next iteration. Bam. And then you see the third nearest neighbors appearing. So you see there's a network of firms evolving. In this case, we look into the ownerships only. Do we see the third nearest neighbors already? Yes, it starts. So. And then you see, well, we go a bit, so then we see Migros appearing. Right? You would assume Migros is a big competitor of Co-op, but there are economic relationship between Co-op and Migros that you can see here when you go along these lines. There are several companies that are owned both by Migros and Co-op. So, and maybe let me just look into this. Yeah, so then you see, you can also move this a bit. Bum, bum, bum. This is just my slow computer, but it's also not very easy to see. So when you see here the Migros appearing with their daughters, and then you see here a number of companies that they link to Co-op, for example. So this is about an ownership relation that we can detect from the database. Right? But there are other features that we can also look up. I'm not sure how well this works, but let me try one thing here. Yeah? So let me go back here to number one, and then instead of the investment network, let's look into the member of board network. So, well, it doesn't work. Okay, so then let me. Oh, it's not better. So then, what about manager network? Okay. Okay, maybe it takes some time. So now we talk about people, right? The CEO of Co-op. How is the CEO of Co-op related to the CEO of Migros? That's also an interesting question, right? So maybe these are complete independent people with their own decisions. So it could be, right? So this is now, I mean, so these are now, it's the manager network where positions are listed. And then we can do the same thing again. We can go along these lines, and then you see people emerging and companies emerging that have a say in this. So, and then we can click on certain people here. Let me just zoom out. And then we see their network evolving. So, okay. The relationship is what these managers have to do with the company. So this is listed in the company profile. It's listed whether you are the CTO of this company or whether you are in the advisory board of this company and so on. And in most cases, you are not only in the advisory board of this company, you're also in the advisory board of that company. And that's the most interesting thing if you think of market regulation, if you think of competition, right? If the same people sit in the boards of different companies, so what's the value of competition? What's the value of regulation? Right? So these are issues. Okay, you see, so I can now click on any of these people here. The people are listed in green, and the grays are companies that connect these people here, right? Basically, it's a bipartite network. And then we would basically see how different managers are indirectly influencing each other, right? So it's an interesting question, but I'm not going to talk more about this. I'm just telling you there is no secret here. Yeah? This is all available in the data. We just need to look at it. So how do we do it? So another, I come to examples later on. Another database that we also use is the Orbis database that has much more firms, in this particular case 19 million firms. We also have other databases available like Bloomberg or Thomson, which basically report on financial data of these companies. So to put it this way, there's a wealth of data available. What is mostly difficult is to link data that belong to different databases to the same company, right? Because mostly even this financial data is not directly linked then to specific other features. So the data, as I said, is publicly available, but I didn't say that it's for free, right? Most people think if it's publicly available, it's for free, right? I didn't say that. Yeah? In fact, it's a very, very expensive database. So we pay a decent amount to have access to this. But everyone who wants can have access to this. You just need to pay. So the data is also not a secret. That's data that companies report officially. So the aim of these companies is they collect this data and fill this into these databases. That's how they make their business. Right? Okay. This is now, once we have bought the database, a simple query in a MySQL database where we can get access to all this data that is reported about a specific firm. So we are not interested in all of these things, yeah? But for example, we are interested in shareholders. We are interested in particular the number of employees in the previous year because we use this as a proxy of the firm size and so on. So you are not concerned with this one. We don't tell you how to query this database. We assume that we did this for you, right? So, but you get the data from this database then already in a cleaned way. That's the first thing. We did it for you. We use one example here for the course. That are the TNCs. TNCs is an abbreviation of transnational companies. Why are we interested in these companies? Because we think that they play a very important role because they operate in different countries. We don't talk about the reason why they operate in different countries, but you can have ample of hypothesis, why it is attractive to have a headquarter in Switzerland or Luxembourg or the Netherlands and so on. So I'm not arguing about it, that's a matter of fact, right? But we look into these companies. And from the Orbis database, we could identify about 34,000 transnational companies. I talk about examples later on. The interesting fact is, where are these companies located? They are located in 116 different countries. That's a very interesting thing. So, and even more interesting, these companies are owned by a small set of shareholders. You see, on average, there are just 2 shareholders per company. A transnational company, I'm talking about big companies here, right? That's not a large number. And these shareholders, interestingly, sit in 192 countries. If you talk about all the industrial countries, of course, yeah, you end up maybe the range of 50, 60. Yeah? So, who are these shareholders if they are distributed in 192 different countries? That's an interesting question, right? So, the other interesting story is that these companies, each of them, owns on average 10 other companies. So you see already a network appearing here. Yeah? So. And these participated countries are only in about 40 countries. So the transnational company, as you can even see from this extremely simple number, is nothing but an organization that concentrates economic power on a very few countries. These are the industrialized countries, while probably paying taxes in a large number of other countries where they may have not a real business in. So, and this collects the money from people in 192 countries, right? So you see, can you see the flow of money? Can you see this? Yeah. So, okay, that's a very impressive thing, I think. So, and then you also see that the top 500 of these transnational companies are responsible for the 50% of the world trade. 500 companies do 50% of the world trade, and 90% of the foreign direct investment of the whole world, right? So that means, so if you look into a subset of 1% of these, you know, 1% of the transnational companies is responsible for 90% of the foreign direct investment. So I hope that these numbers, if you play a bit of imagination, already ring a bell of how the economy is structured. It's extremely skewed. That means the power, the economic power, is in the hand of a very few companies. Yeah? And also the financial power, because the foreign direct investment is ruled by these companies. Nevertheless, these companies are not very large, so we looked into two extreme cases here. General Motors is the largest one with 280,000 employees, but there are also small ones with 22 employees in this data set. Right? So this is Empirics. And now then we have to think of what is the story behind this? What do we learn about economics when we see these numbers? We will do more on this in the course. But we look now a bit into the structure of these companies. So we took one example here and looked into the classification of their business, because we would like to know what is the business that these transnational companies do. Right? So, and there is a classification for this. It's called the NACE classification. In the notes I have explained a bit more about the NACE classification. That is used in the European community. It's a 4-digit number to classify your kind of business. There is another set of classifications, the ISIC classification, International Standard Industrial Classification. That's mostly used in the US. So I give a few hints here, though. That means each company in this database is classified according to its main business. So we took one example here, Fiat. So you probably know about Fiat, right? So what do you think is the main business of Fiat? Cars? Other ideas? Okay. So Fiat is classified, it classifies itself, yeah, by this number. So we looked it up here, code 7415. Okay, so 74, first of all, it belongs to section K. I wrote it here in the notes. Yeah? And section K deals real estate, renting, and business activities. So, and 74 specifically means other business activities. And 74.1, those are the 3 first digits, relates to business and management consultancy holdings. So different from you, what you think about Fiat, Fiat is a management company, right? It runs on consulting business, on renting, and other business activities. Okay, that's a very interesting thing, right? Cars do not exist in this kind of classification, right? And why is this? Because Fiat owns other major plants and branches that produce, for example, cars, but also other things, right? So we need to understand this structure. Okay, this is one example, yeah? So when you go through this here, then you see, if you look into what's the business of all these transnational companies, then you see that only a small minority is really doing business in the primary sector. So that means the primary sector is where you transform natural resources into some sort of primary products. Yeah? So, and only 10,000 are in manufacturing. That means they use the primary product to build a car or something like this. Yeah? But about the same size is in the service sector, and about half of this manufacturing size is in the financial sector, which is not related to any sort of industrial production, of course. Right? So, and the most of them are as Fiat in real estate renting and business activities. Okay? That's a very interesting thing if you think about the economy. So we learn this from the data. Here is another plot where we try to sketch this also with the respect to the countries. So here are the transnational companies. The transnational companies have subsidiaries, or it's also called here participated companies, that are companies they own, either jointly or exclusively, right? So that's on this level. And at the same time, they are owned by these shareholders, right? And of course, the shareholders can also own these participated companies themselves to some extent. But remember the numbers, 192 countries, 111 or 116 countries, 40 countries, right? So you see what's the meaning of a transnational company and also the purpose of a transnational company. It very much concentrates the economic power in a few and the financial power in a few countries. So which are these countries? So you see that the lion's share is here in the Netherlands, for example, Germany, Great Britain, the US. So why do you think the Netherlands is so important here? Last year there was someone from the Netherlands who could explain this precisely, okay? What's so special about the Netherlands? Any hint, any clue? Why are the companies all in the Netherlands? Any argument? What do you guess? How many? Regulation, yes, and in particular taxes, right? So these companies move to those countries where they find the best economic conditions for their development, right? And remember, these companies themselves do not need to do some business, right? Each of these companies owns on average 10 other companies, and these companies do the business. You understand what I mean, right? So, okay, then we can argue a bit what's the role of these different countries here. So I'm not going to do this. But there are interesting stories behind this. This is simply an empirical analysis, right? I don't start a discussion on policy, on regulations, on these things here. So, but this is what we can simply get from the data. And there is also this very nice paper. I think I also mentioned it in the notes. The network of global corporate control, which made it then to the news in several countries. Occupy Wall Street people, so they have it in their hand. So I saw it on TV, and they said, okay, there is the scientific proof of what these people do to us, right? So here, the Swiss scientists, they found it, yeah? How we are used to be exploited. Okay. Anyway, let me come to more concrete things afterwards. First thing is, I hope with this simple example that I have to convince you that industrial dynamics and the structure that we have just talked about is a very interesting topic per se. It's an empirical problem. That means you can learn from these things, from data, once you have generated hypotheses of what you would like to ask. So, specifically, what we would like to find out is about birth and growth processes, but also about decline and growth and death processes of different parts of the industry and of firms in general. So what are the conditions here? I try to convince you that there is a direct impact on specific policy issues. Think of unemployment, think of market regulation, and so on. We are able to look into data, so we are not just sitting here and speculating and writing down mathematical equations and do proofs on all these things that are usually done in economics. We are also able to do real empirical work here. Our aim in the first round is to understand, are there any structures behind it that are robust? Yeah? Things we observe in different data sets, stylized facts, so statistical regularities. And if we identify these, that's of course the first thing we do, then we have to ask, how can we reproduce these stylized facts? What's the underlying dynamics in the interaction of firms that gets us to these stylized facts? That's the question here. So, and we have to do two steps now. The first step is we need to extract the data we are interested in from these databases. I can tell you that my graduate students, Stefania Vitali and James Gladfelder, spent a year each to get this data out of the database. Yeah? I'm just telling you that this is nothing, then it's not the same as pressing a button, yeah, and then you get something, okay? You have to check this data for consistency, you have to clean the data, and then after 6 months you find out that by analyzing the data, you find some very important companies you have never heard of in your life, right? So, and then you are extremely proud because you have detected the hidden node, right, that controls all of the economy just by your analysis. But then it turns out that it was not the hidden node that you detected a bug in the database that a person employed by this company made on a particular day. It was a bad day for this person, right? So he mixed up a few numbers. Simply by this mistake, so some complete unknown person winded up the hierarchy and became number 2 in the world, right? So, okay, yeah. This is then a bad day also for the PhD student, of course, because then first of all we have to complain to the vendor, and secondly we have to start from scratch, right? So, I mean, with the analysis. So this happened in this particular case. So we are not querying the database, we assume someone did it for you, but what we do now is we talk about extracting the regularities, and then we have to talk about the software that we are using here. That is R. Who has experience with R? You already? In what context, please?
I had a course in computational physics and common physics.
With Dieter Wirtz. Okay, good, yeah. Okay, who else has, yeah, you? So, who else? No one, okay. Okay. Why did we use R? So, the first sentence says it already. R is the state-of-the-art statistical software package. So it's vastly accepted in all kinds of communities, not only in the industry, but also in science. Even in social science, where you think, okay, people are not so much in heavy statistics or modeling or so. There is a huge community just developing R, and there are own conferences on finance and econometrics, so which entirely focus on R. So, just for your information. I have put in the self-study a short article from the New York Times, which I encourage you to read in order to find a few more arguments why this is the state-of-the-art software. I'm not going to comment on this. You know? So, the most important thing for us is it's an open source project. And the second one, ETH Zürich is heavily involved in developing this. So Dieter Wirtz does a lot on these financial statistics packages, but there are also other people here in the Institute of Statistics. There's also a course by Mr. Mechtler and Professor Bühlmann on computational statistics, and they do it the same way we do it here. So therefore, what I have chosen here is, if you want so, the canonical way of doing it. You know? So, okay. So we will not use many of the tools that became available in this community, only a few, but it allows you, after you did all the exercises with R, it allows you to fully use this package. Yeah? So, okay. The second important program we are going to use is GNU Emacs. So, RS is statistics software, but this needs to be run and edited in an editor. And we have chosen the GNU Emacs editor. What did Dieter Wirtz choose, or the GNU Emacs, or what did he choose? You were free to choose. And what did he recommend? RStudio, yeah. We also recommend RStudio if you like to have a graphical user interface and so on. So that's written up in the self-study tasks 1. Pavlin recommends you or tells you how to download RStudio. That's a graphical interface. So, why do I still keep the slide about GNU Emacs? RStudio is specifically targeted at using R in a graphical user interface. GNU Emacs is targeted at doing everything. Right? That's a difference. So if you learn GNU Emacs, then you have a tool you can do everything with. You can write your diploma thesis, you can have a file browser, you can have all sorts of things. Right? So that means by going the way we recommend, you learn more than just the RStudio. Yeah? Of course, you lack the opportunity to click on certain things. Yeah? But maybe you get to the point where you find it useful to not click on certain things. Yeah? You learn a number of shortcuts, and then basically that's it. And this gives a boost to your productivity that you do not realize initially. In the initial phase, you usually think, so why do I need to learn about this program, right? Because it's not this graphical user interface stuff. But in the second one, you recognize that you are much, much faster in handling these things. So our student assistants all have to work with GNU Emacs because we generate these slides in TeX. What do you think, how many TeX files do we have for such a course? Do you have an idea? Just say a number. Individual TeX files for such a course. Any idea? Now let's say 300, okay? So these are 300 individual TeX files on different topics that are then sorted in master files that gives this lecture, okay? And now let's assume, so I want Natalia to change the sentence about Richard Stallman, who gave a talk, I think, last year here at ETH Zürich, so it was completely crowded, as Marcelo told me. So that's the inventor of this Free Software Foundation. And so let's assume she needs to find this in the 300 different files. I mean, how is she doing it? I mean, technically, right? Or we have made a misspelling something, resources always with 2S or this kind of things. Okay, it's a consistent misspelling. How do we fix this in 300 different TeX files? That's something that happens, right? Oh, I write my diploma or master's thesis, then I have 50 different references that I want to include. How do I do this technically, right? These are all things that are already implemented in GNU Emacs. So once you deal with this and you recognize, okay, that's not just useful for using R, it's useful for everything. That's why I'm talking to you about it. And by the way, as far as I understand, Mr. Mechler and Mr. Bühlmann also do it this way. Yeah? Okay. I encourage you to do this step, right? I do not remember that people ever regret this. But I remember a couple of people who thought they know it better and never tried it. Okay? So I meet these people quite often. So, okay. These are two open source software projects, both R and Emacs. Why are we using open source software? So there's also a principal reason for this. I have to watch the time. There's also a principal reason for this. Open source software has the advantage of being developed by a vast community. So that means neither the intellectual property rights are owned by a company, nor is this company controlling the development of this software. Instead, what we have here is a much more flexible dynamics in developing this software. If there is a need on the user side, this is much more frequently implemented in the software because there is a strong interaction between the users on the one hand and the developers on the other hand to implement these things. So that means from our side there are lots of advantages. And we also contribute ourselves, I mean my chair contributes to different parts of open software projects, not just related to R, but related to other things. For example, we have developed the style files used by ETH for the official letters or these presentations and things like this. So we do a lot of things in this direction. We have also developed a software to visualize small-size networks, so called Cuttlefish. You find different hints on our website on this. Okay. Why don't companies use so much of open source software? Many companies do, and you have seen before that I run Eclipse, for example, yeah, to show you the network browser. So that's Eclipse is an open source software that is hosted by IBM, right? It's an open source software, but IBM considerably contributes to the development of it and provides the infrastructure because there are about like 30,000 people, yeah, 30,000 nodes in the software that need to be developed, right? So. Okay, but most companies refuse to use open source software because there is no one to blame if something does not work, right? So, and if you are the CEO of a company, and then you say, well, we can talk about the price. But if something goes wrong, then I want to have someone to blame for this, right? I want to pick up the phone and want to have someone on the other end, yeah, who promises me to have the solution in half an hour or a day, and if not, then he's out of business. That's a mental thing, yeah. So, if you have to see it from the side of risk management. Of course, you pay, yeah, but this gives you a more smooth way of managing the risk associated with using certain software, and this cannot be guaranteed with open source software. Nevertheless, there are many companies that use open source software or provide services for open source software. Even that they do not develop it, they provide a service for this and say, okay, we are the one to blame. Yeah, we fix these things for you. Okay, yeah. So this is something that you should understand. But what I would also like you to understand is there is no disadvantage, I mean, in terms of performance or productivity if you go and use open source software. You will see that this provides the same quality as something you pay for. Right. So, okay. This is something you can read at home. So there is the OSS analogy of the cathedral and the bazaar. So we have used this here from other talks about open source software, just to give you more insight into the mental framework of developing software. So, and most proprietary software is following this cathedral-like software development, whereas the bazaar-like software development is a metaphor also for open source software. You can read it at home, yeah, if you want. So with this, I come to your first self-study task. You go to the website, you download the self-study task, and the best thing you can do is you read it loudly and do everything as described by Pavlin and Natalia. Yeah? It should be complete, smooth, and error-free. Okay. You have to learn how to get started with R, with Emacs. So, and ESS means Emacs Speak Statistics. That's this particular package for Emacs that helps you to run R code in it. And then you have to, so this is now related to 10 after 11. So we still have 5 minutes because we started 15 after 11. Okay. And then you have to do one little thing. You have to write the R code for plotting a normal distribution, have to include the picture into the deliverable and send this picture to Pavlin. Okay? So, estimated time, I don't know how much time you need to install R and Emacs. I don't know that. Yeah? So, but once you have installed this, the estimated time for this is about 60 seconds. You got it? So the estimated time after you installed it is 60 seconds. Yeah? So in order to convince you, I type this now. So that's exactly what you have to do then. So I mean, I have, of course, installed R and Emacs now. So I do exactly what's written here on this side. So I first run. So Emacs is already running, as you see here. So I start Emacs R mode. I just type this here. Yeah? So okay. All right. So and then I start R. So it asks me what is my starting directory. Would be nice if you use always the same starting directory, because then you have an R history of all the things you already processed in R. Yeah? So I just accept this default folder here. Oh, go down here. Documents, right? Can you see this? Is it possible? So then I get a error message, cannot read history file, R history. That's obvious because in this document folder there is no file about the R history, right? But if you always use the same directory, then you do not get this. It's basically not an error message, it's a warning, right? So, okay. And you see that already your screen has changed to some console-like format where you just type what I wrote in the handout. So you create a file where you later save your R code. So file create. So let me call this, as in the example, test R. Okay, bam. True means I got it. So then you have to plot a function, and the function, for the function you have to specify the x coordinate and the y coordinate, right? So for the x coordinate in this example we assume that you have to plot it in an interval between -5 and 5. So that means I assign to the x a sequence of values from -5 to 5. So, and now I have to give the raster, so by equals 0.1, okay? So, and what about the y? The y should be the normal distribution, right, our function. So we hope that someone was already nice enough to implement this, right? We gave you the name of the normal function. It's called d norm of x. Right? So, okay. And now we have to tell to plot. So plot is plot, and then what do we have to plot? X, y, and then I type types so L means line. If you don't specify the type, you get dots. You can try with this. Yeah? So then there are two other things. So Cx lab equals 2 affects the size of the x and the y. If you want to see what this is doing, you just change the value to 5 or 1 or something, and then you see what's the effect on the graph, right? So, and Cx axis gives you the size of the axis description, yeah, of the numbers. So, 2. Bam. So that was it, right? So you type these 3 lines, so now it's 12, so, and we are done. You type these 3 lines, and then you get this plot here. You can try with the different parameters. You save this plot. It's also written on the slide how to save it, and then you include it in your presentation. That's it, yeah? So we made it that simple in order to give you a quick success. That you see it's very easy to learn about this. So that's the result. I can go back here, just 1 second. So that's the success, yeah, the picture you have just seen. Okay, and these are the questions you should answer at home in order to recapitulate what I said in the course. Next week we are going to get more to the details, so where the meat is. So we start by describing data sets and by treating them in a mathematical and statistical way. So next week I'm not having all these slides with the bullet points. I'm having more equations. I'm having more pictures there. And I hope that many of you will join us next week. Yeah? And in the meantime, you just install R, and then you use Emacs. That would be my recommendation. If you use R Studio, there's nothing wrong with doing that. That's a graphical interface. Yeah? It's also a standard interface. But there's this other one was my recommendation. Okay, thank you very much, and see you next week. Basically, for you to take notes. It means I expect that you have a few important notes to make during the lecture here. That's the idea. So therefore, some of these fields are empty, so you can fill them up. The second important material you find there are the self-study tasks. I will comment on this a bit later in detail. Each of the courses we teach has a theoretical or upfront teaching part and a self-study part. We want you to learn something. We want you to do something yourself. And in our particular case, the self-study task is about dealing with data, learning how to get certain features that we describe theoretically in this course, how to get this yourself, and to compare the figures that I show here with the figures you produce yourself. So no matter whether you care about firm dynamics after this course or not, this is some skill that you can use in most other fields. Let me remind you on this. Then we also put literature in the Moodle platform. This is meant as an additional information to you. Sometimes you would like to look into the original paper. What did the author say about these figures in comparison to what I said about it? Then this is available to you. We encourage you to look into these things. Sometimes also interesting for historical perspectives. And you see how Herbert Simon has argued about these things like 50 years ago. That's also interesting. But it is not part of any further check or control. Then we also give you parts of code that you can use, in particular code for the statistical software R, that you can use in order to run your own programs and to educate yourself. And last but not least, the Moodle platform is also for communication. Communication among you. There is a forum where you can discuss about the self-study task, but there is also a forum where we communicate to you. So who is we? The professor, of course, but also the assistant of this course, that's Pavlin Mavroviev. I'm not sure if some of you have met him before in the lecture Systems Dynamics and Complexity. Who attended this? Okay, so then you know Pavlin already. Pavlin has developed most of the self-studies for this course, so he is really the skilled person to discuss why certain things may not have worked out for you and so on. There is also a student assistant working for this course, Natalia Frey. She is responsible, for example, fixing the errors that we detect every year. So we also redo the slides every year. That means we produce new errors, and if you see one, then please point us to this. Oh, what did I do? I pressed something, right? The S was not intended. All right. So I have to be careful here. Okay. So the exercises are mandatory in the sense that you first have to submit something to Pavlin. That is why we use the email address that is on front of the handout. So that's an email address you should write to regarding everything about the course. You can also write me personally, so then it's read by my office administrator. If you want to write about the course, and you write on this address, and then we look into this. Okay. So the groups, you should form groups in order to solve these exercises. Dynamics from a systems dynamics point of view. So that means we deal with nonlinear equations, and then we look into control parameters that allow us to reach different scenarios and so on. But we never explain how we get the systems dynamics, right? If you think of whole issue from a conceptual point of view, then there must be some entities, economic actors that interact and generate the systems dynamics. It's nice that we can afterwards describe systems dynamics by a set of nonlinear equations, but how do we get that? So that's a challenging question, and this question is answered in this course. And to some extent also answered in the economic network course. So let me start with a few formalities here. Let me move this. The course is an elective course in the MTech Master Program. It's also listed in other programs like elective course for physicists. Is there any physicists here? The two of you, good. So you will probably recognize that what we are doing is very much inspired by statistical physics here. That's on purpose, yeah? So, okay. It's also listed in mathematics, no one, and agriculture, I think. Yeah. We have provided you with a website in Moodle where you find all the material. What do we mean by all the material? We mean these handouts, and I managed to inform you in due time that you should hopefully download this. The handouts contain all the slides that I show in the lecture and a note field. Sometimes I write the references to literature that we have used in order to create the site. Sometimes I give general comments on how to understand the slides or things like this. But the notes part is so, good morning, everyone. I welcome you to our course on collective dynamics of firms. My name is Frank Schweitzer. I'm a professor of systems design at ETH Zürich, and I will teach this course myself. I hope that a few more of those students who have subscribed will appear here. So there are actually, I think, 26 or so that have subscribed to the course. If you happen to know why some people are no longer interested or drop out from the course, so we would be really interested to know this. Some of you may have realized that I teach 2 courses during this semester. The other course is on economic networks. Is there someone participating in both courses? You, right? So for all the others, there is some overlap, of course, in subscribing to these courses. Economic dynamics, I would say, is the most advanced course we teach. At the same time, it's also discussing formal concepts a lot. This course is not as ambitious as economic dynamics. It's more hands-on. You do something, you do a bit of math, something you know. You deal with equations, you deal with data. It gives you a more comprehensive view of a real dynamics. And what I like about this course is that the things you learn here in terms of how to treat data, how to build models, that's something you can use in many other areas of scientific disciplines. So this is not very specific on companies. So if you ask me which of the courses I like most, then I can say this one, so, okay, of my courses. I also teach another one in the fall. It's called Systems Dynamics and Complexity. This is a very basic course. It basically covers to discuss certain things as well. And these groups will be randomly assigned. Pavlin will usually do this. He will also take care if some new people enter the course or some people drop out and rearrange these groups. It eases the effort of doing the exercise and presenting something here. Okay, you can read this in detail. Then we have a test start every month. That is an online test start, which you do at home. Basically an open book test, if you like, where we just control whether you were able to follow this course. You have hours enough to do this test. You can use all your material in order to answer these questions. This will be multiple choice questions. It is simply to give you an additional feedback about what you understood from the course and what not. And for us, it's a good control to see the same. You have to pass 2 of these test starts in order to be eligible to take the exam at the very end. If you do not participate in the exercises, that's the other condition, and if you do not use the test start, we are pretty sure that you are not able to pass the exam. So these are mandatory conditions for good purpose. And then we have a Sessionsprüfung, an exam during the summer break, which is arranged by the rectorate. It's a written exam, closed book, no additional help material, but it covers not only the lectures, it also covers the self-study tasks. That's very important to understand. Are there any questions from your side regarding these formal things? If not, then we